Bismillahirrahmanirrahim. Assalamu alaikum, students. Students, today we will discuss the problems of the nuclear physics, the chapter number 30. Already I have discussed with you this chapter. So in this chapter, I've just go through this chapter. So this is the nuclear structure, radiation and radioactivity, nuclear decay and half-life. These are the articles which is included in this chapter. So in this chapter, first you remember that you have studied this nuclear structure. So in this nuclear structure portion, you have to remember this formula. So A is equal to Z plus N, or this symbol is very important. This is A and this is Z. Okay, so A is called the mass number and Z is called the atomic number. So already we have discussed. And similarly, you know that we have discussed about the isotopes. So after this, now we have this question. And in this question, you can see the isotope of helium He23 has dash neutrons. So how many neutrons? So already I have discussed with you that to find the number of neutrons, what you have to do, you have to uh, do this one A minus Z. So A minus Z mean 3 minus 2 and 3 minus 2 is equal to 1. So answer is this one. So always subtract up minus down for neutron. And similarly, how many neutrons are in each of the following isotopes? Some of these are uncommon or unstable. So this is just information. So here you can see he has already solved this problem. You can see that lithium 11 minus 3 is 8, 11 minus 4 is 7, 11 minus 5 is 6, 11 minus 6 is 5 neutron. So you should know that how to find the number of neutrons. Second thing, radiation and radioactivity. So already I have discussed with you that how to find the alpha decay, beta decay, and gamma decay. So last time you remember that this formula is very important to find this um, alpha decay. So here you can see that Z is decreased by 2 and A is decreased by 4. And here alpha particle is emitted. Alpha mean 2He4. This one is produced. So alpha mean helium nuclei. So here you can see the various examples are given. Here you can see the um radium is a heavy element that is produced by decay of uranium. So here the radium is converting into radon and 88, 86 to 22. So 2 decreased, Z is decreased by 2 and A is decreased by 4 and alpha. So already I have discussed with you. And the next is the beta decay. So there are two kinds of beta decay. One is negative beta decay and one is positive beta decay. So here you can see the negative beta decay, beta minus decay of nucleus is Z is increased by 1 and A remains same, and here E negative. So E negative mean minus beta decay. So beta plus decay, you can see that in this case that Z is decreased by 1 and A remains same. In both case A remains same, but here is decreased by 1 and Z is decreased by 1 and A remains same and E plus. So these are the examples of beta decay. And similarly, we have discussed the gamma decay. In gamma decay, you remember that first we have to make any atom in an excited state by emitting alpha or beta rays. And when it is it is in excited level, then when it will be de-excite, then they will emit gamma ray. So here you can see in case of gamma, there will be no change in Z and A, and this hysteric mean that it is in excited state. So when it becomes de-excited, then it will release gamma. So here the example is given. Now they will ask the question, is polonium and in this uranium converting into uranium plus alpha a possible decay mode? So here you can see that here it is converting into 2. Z is decreased by 2, and but A is not decreased by 4. So it is not alpha. So we will say that it is no. Okay, after this, what is the daughter nucleus for the following decay? So daughter nucleus mean that this is called your parent. This is the parent nuclei, and this is the daughter nuclei. Daughter nuclei. So here you can see that it is E minus. So E minus mean it is beta negative. So here you can see that Z is increased by 1 and A remains same. So I think this is the answer. So similarly, what is the decay mode of the following decay mode of the following? It is alpha decay or beta decay or what? So here you can see it is 55, it is 56, and here it will be beta plus. So in beta plus, it is increased by 1 and it remains same. So similarly, what is the decay mode of the following decay? Now you can find it very in a very good way. So this is excited state, and this is after de-excitation. There is no change in A and Z, and what will be here? It will be gamma. So the answer will be gamma decay. This one. So after this, now we have the actual part of this numerical portion of these articles. So you should remember this formula very carefully. This is very, very important. So here you can see the number of atoms remaining after time t, this n, or we call it undecayed. These are undecayed, and these are the total number of atoms at the starting position. This is total or initial. And here you can see the T is the time, but T half is the half-life. Half-life is the time in which half of the element decay and half remains undecay. Here you can see this graph I already discussed. So the nuclear decay and this formula, they have written this formula in different ways or different styles. So styles mean this one, n is equal to n naught. We can write e raised to power minus lambda t. Okay, so t is the time and lambda is equal to 1 over tau. So you can write it n naught e raised to power minus t over tau in this way. So that's why they have written in this form. And also lambda is equal to, what is lambda is equal to 0.693 over t half. This is lambda, and lambda is also equal to 1 over tau. You can write it 1 over tau is equal to 0.693 over t half. So you can write it in another form that tau is equal to what? T half divided by 0.693. 0.693 mean log of 2. This is log of 2 actually. So these are the different styles or different forms of this equation. Okay, after this, now they have nuclear decay and half-lives formula in different forms, but we will use this one, how to solve the problems. Okay, here you can see that in this problem, 100 gram of radioactive elements X are placed in a sealed box. The half-life of this isotope of X is 2 days. So here 100 gram. So it means you should write this one. 100 total is the n naught value, and this is the 100 gram. Actually, it is, you can write it m naught or n naught, any value you can give. But normally we are written in n naught because we are using the number of nuclei. So the half-life is 2 days. So you can write here T half is equal to 2 days. After 4 days. So after 4 days mean this is the time. After 4 days, this is 2 days. Have passed, what is the mass of the element X in the box? So we have to find the n value. So what is the n value or what is the m value? So apply this formula. N is equal to n naught 1 by 2 and raised to power n. And n is equal to t over t half. T mean time over T half mean half life. So T over T half is equal to what? 4 over 2, and this is equal to 2. So this is equal to 100 into 1 by 2 raised to power 2. So this is equal to 100 over 2 raised to power 2. So 2 raised to power 2 is 4, and this is equal to 25. If you cancel this one, it is 25. So the answer will be this one. So in this way, you can solve this problem. This is very important, and understand this one. Okay, after this is the problem about the half-life. So this is the activity definition. The activity definition is the activity R of a radioactive sample is the number of decays per second. So number of decays per second, how to find this one? So you should remember some formulas. The formula is equal to R is equal to N over tau. And also he has put the value of tau. So the tau value is, this is tau or 1 over tau. You know that lambda is equal to 1 over tau. And tau is equal to 1 over lambda. Like this one. You can write in this way also. So you should know that lambda is also equal to 0.693 over T half. Now he just substitute this value 1 over tau. 1 over tau mean lambda, and lambda mean this one. So he just put this value in this way, and this n is here. Okay, so R is equal to lambda into n. R you can write it n over tau. You can write it like this one also. Okay. So here activity is inversely proportional to half-life. So you should remember this statement. This is very important. So also they have write this formula in another form. And another form is what? So you should remember this one, that R is equal to N naught. R is equal to N into 0.693 over T half. And N is equal to what? We have already used this formula. N is equal to N naught into 1 by 2 into N 0.693 over T half. So here N is equal to what? N is equal to T over T half. Now this formula has every thing is clear in this formula. N is equal to T over T half. T is time. T half is half life. N naught is initial, and R is the activity. So this is the complete formula which you should remember this one. Very important to solve the problems. Okay, the units, you should remember the units of the activity unit is becquerel. And 1 becquerel is equal to 1 decay per second, like this one. The Curie is another activity unit that can be used. 1 Curie is equal to 3.7 into 10 raised power 10 becquerel. Okay, now see this example. So in this example, we will use the same formula which I have written before, like this one. So here you can see we consider a sample that contains 3 into 10 raised to power 16. So this is actually equal to N naught. I write it, N naught is equal to 10 raised to power 16 nuclei. Okay. And T half value is given. This is your T half. And T half is equal to 16 years. Now, what you will do? You will convert this 16 years into second, and you can see that he has used this value. So 16 is into years. In 1 year, how many days? 365. Okay. In 1 day, how many hours? In 1 day, 24 hours. And in 1 hour, how many minutes? 60 minutes. How many seconds? 60 seconds. So when you solve this one, you will get this value. Okay. Now we want to find what? What is the activity of the sample at T half? T is equal to T half. So when T is equal to T half, we have to find the activity. So to solve this problem very easily, you should apply this formula. R is equal to N naught into 1 by 2 into N into 0.693 over T half. Now I am putting the values. N naught is what? 3 into 10 raised to power 16, this value. So 3 into 10 raised to power 16 into 1 by 2 into N. So N is equal to what? So N is equal to T over T half. So T and T half are equal. So N is equal to 1. So that's why N is equal to 1. And this is equal to 0.693 over T half. So T half we have already found into in terms of second. So that is 5 into 10 raised power 10. Now you can solve this one and get the answer. And answer will be in this form. So the most important thing in this problem is what? You should remember the formula. R is equal to N naught 1 over 2 N into 0.693 over T half, and N is equal to T over T half. According to the statement, T and T half are equal. If they are equal, then N is equal to 1. Otherwise, they have some value. Okay. So remember this one. So here in this summary portion, so they have written the nucleus is a small, dense, positive core at the center of an atom. Z proton charge plus E and spin half. So remember the spin is always half, up, half spin up and half spin down like this one. But just to remember this one, half spin. Okay. After this, the general principle of this one. So this is already we have discussed alpha decay, beta decay, plus and minus. So these are the problems. Again, you can see identify the unknown x in the following decays. So we have to check the equation. So in this equation, you can see 86 to 84. So z is decreased by 2 and a is decreased by 4. So surely x will be alpha. Alpha mean helium nuclei. So alpha mean it is helium nuclei. Helium nuclei mean 2H like this 4. So similarly here 88 Z is increased by 1 and it is remain same. So what will be B reaction? It is beta negative. So here you can write beta negative or here it is written beta, E negative. So same thing. And similarly C is also same. And in D case it is increased 29 in and 1 it is decreased by 1 and it is remain same. So this is beta plus. So similarly you can find the identify the unknown isotope X in the following decay. So here you can see that it is if this is alpha, then alpha is what? X will be what? So surely the X will be this is decreased by 4. So decreased by 4 is 230. But here Z value is not written. So just understand this is the answer. And this is the answer of the B and this is the answer of the C. This is the answer of the D part. So when it is gamma, then it is not changed. So X here it is 30 and E plus. So you should know that it remains same. A remains same. And here is the sulfur E negative. So this is 32. And when it is negative, so surely it is negative or it is positive, the up value always remains same. Okay, after this, now we have to solve this problem. This is another problem, okay? So in this problem, he is asking a radioactive sample has a half-life. This is the half-life. Half-life mean this value is given in 2 milliseconds. So I change this color and then maybe you can understand very well. So half-life means that T half value is equal to 2 into 10 raised to power minus 3 second. It is given. 10 raised to power 6 nuclei mean N naught is equal to 10 raised to power 6. Are present at T is equal to, this is the time is given 4 into 10 raised to power minus 3 second. Now the question is, how many nuclei were there at t is equal to 0 millisecond. Okay, so we have to find how many nuclei. So how many nuclei were there mean we have to find the n naught value actually. How many nuclei were there? Initial was what? So this is actually the value is not n naught. This is the value of actually n value. Here I write n naught. This is wrong. So how many nuclei are left at t is equal to 0? Mean initial value he is demanding. So initial value mean he is asking about n naught. Now the formula is same. N is equal to n naught into 1 by 2 raised to power n. So apply this formula. And to apply this formula, what you will do, n value is given at 4 millisecond, mean at this time. So this is 10 raised to power 6. This value is given. N naught we have to find. 1 over 2 n. Small n is what? T over t half. So t over t half mean 4 over 2 into 10 raised to power minus 2. So this 10 raised to power minus 3 will cancel. So answer will be here 2. Okay. Now you can solve this one. How to solve this one? So this is 10 raised to power 6 and this is equal to n naught over 4. So 2 square 4. So you can write n naught is equal to 4 into 10 raised to power 6. So in this way you can solve and the answer is here 4 into 10 raised to power 6. So similarly you can solve this problem. The next part, how many nuclei will be there at t is equal to 8 millisecond. So apply at time, this time is given 8 millisecond and solve it and in the same way, in the same style. Okay. This is this problem. I make it here a line. No. How many half-lives must elapse until 90% and 99% of a radioactive sample of atoms has decayed? So we have to find the how many nuclei decayed. So nuclei decayed mean n naught minus n we have to find. So first what we will do? First we will find the n value. So apply the formula n is equal to n naught into 1 by 2 raised to power n. Now you can solve it. Uh, so n over n naught. So n over n will be what? So here you can see he has written the value of 0.1. So this is it means that if 90% must have elapsed until 90%. So the remaining will be what? Undecayed will be what? 10%. So it means this is the answer of 10 and n naught total will be what? 100. And this is equal to 1 over 2 and raised to power n. Okay. So in this case, you can solve it for this n value. So here you can see that n naught is 10% and n naught is equal to 0.9 into n. They have solved in different way and different styles. Okay. So actually what we have to find, we have to find this n value. So n value mean we want to find the t over t half, actually t over t half. So you can solve it by taking the log of this value. So 1 over 10 is 0.1 is equal to, I just write here, 0.1 is equal to 1 over 2 into n. So what you will do, you will apply the ln, ln 0.1 this side and n into ln 1 by 2. So n is equal to ln 0.1 divided by ln 0.1 over 2 is 0.5. Now you can solve this value and your answer will be this n is equal to what actually? This n is equal to actually t over t half. So you can solve this one and get the answer and t is equal to this factor multiply by t half. So that's why he has written this answer. He has written this answer. So answer here will be 3.32. Now you can solve it, that log of 0.1, I check here, log of 0.1 divided by log of 0.5. So if you solve this one, then its answer is 3.32. So that's why I write here 3.32. So t is equal to 3.32 into t 1 by 2. So this is the answer. So similarly, you can solve this one. So this you will solve. Here I solve 10 over 100. So this will be your 1 over 100, because here is 90 and here is 99. Mean it is one, n is 1 and n naught is 100. Total is 100. So 1 over 100 and then solve it in the same way, in the same style. Okay. So this is a little tricky, and understand this one. So the next is the cobalt 60 decays to the nuclei isotope. The decay process is what? So here you can see it's 60, 60, and it's 27, it is 28. So it is increased by 1. When it is increased by 1, it is beta minus decay. Okay. So he is just asking this question. So after this, now solve this problem. In this problem, a nucleus A decays to nucleus B with a half-life of 10 minutes. So half-life is given, and that is, I write here, 1/2 is equal to 10 minutes. No need to convert it into second, just wait. So a pure sample of nucleus A contains, pure sample mean initial, the full sample, so full value is what? That is N naught, and this is 24,000 particles. After the 30 minutes, so 30 minutes mean this is the time, and this is 30 minutes, it is given. Minutes, the sample will contain, what value? So simply apply the same formula, n is equal to n naught into 1 by 2 raised to power n. So n naught is 24,000 into 1 by 2 into n. So n is what? T over t half. So t is 30 minutes, and t half is also minutes, it is 10. So this cancel, it is 10 raised to power 3. So 24,000 divided by 2 raised to power 3, and this is equal to 24,000 divided by 8. So when you solve this one, the answer is 3,000. So your answer is 3,000 gram. Don't say that this is the answer. This is wrong. So it is actually undecayed you have find. So how many left in the A? He is asking actually this in the B. He is asking this one. So the total is 24,000. Total is 24,000, and the undecayed is 3,000. So what is left in the B? It is 21,000. So that's why the answer is this one, not this one. This is not answer. Okay. After this, now you can see a sample of 1,000 radioactive atoms has a 10-minute half-life. In the same way, in the same style, you have to solve. These are very important problems, and you should apply the formula. I write it here, that n is equal to n naught into 1 by 2 into n. So what is n naught? 1,000. This is 1 by 2 n. N mean t over t half. So here you can see how old the sample when atoms have decayed. So what we will do, we have to solve this problem. The decayed is the 750. Decayed is 750. So undecayed will be what? Undecayed will be 1,000 minus 750. Minus 750. And this is equal to 250. So this is 250. So n, actually n is undecayed. So n is undecayed. So we write here 250, and this is 1,000 is the initial, and n value is what? N value is time, over t half. So t half value is given 10. It is 10 minutes is given. So solve this one. So if you solve this one, this will be 4. So 1 over 4 is equal to 1 over 2 into t over 10 minutes. Now you can same apply the this ln formula. Here ln 1 over 4 is equal to t over 10 minutes multiplied by ln 1 by 2. Now you can solve this one. Okay. So solve and write the answer. Okay. So you have to find the t value. So the answer will be t20. This answer will come this one. Okay. Here he has solved, but he has solved in a shortcut way. But you should apply this formula in this way. This formula and first find the undecayed, because n mean this capital N mean this is the undecayed and this is the total number. So same the barium isotopes has a half-life 10.5. A sample begins, and now you can solve it in the same way, in the same style. How many are left? So we have to find how many are left. So find the n value. So n is equal to n naught into 1 by 2 raised to power n. So half-life is given. A sample begins with this value, and this value is actually your n naught value. 1 into 10 raised to power 10. Okay. How many are left after 2 years? This is the time. So you can apply the formula. N value is what? T over T half. So T over T half mean the time is 2 and T half value is 10.5. So remember the units here and here is the same. So that's why I'm using the same units and I have no problem. Now you can solve this one. So you can solve it in the calculator very easily. Okay. So this is the first this question for 2 years. So after 20 years, just put here 20 and then solve. After 2000 year here, put here 2000 over 10.5 and then solve. So in this way, you can solve this problem. So the last problem is the cadmium isotope has a half-life of this one. So this is your T half value. Okay. A sample begins. So this is your N naught value. This is your N naught. And how many are left after 50 days? So this is your T value. Okay. So just solve for N. N is equal to N naught 1 by 2 N. So using the same formula, and this is 10 raised power 12 into 1 by 2 into N. N is what? T over T half. T is 50 days in the first case. So here it is 50 divided by T half 462. So in every case, the T half remains same, but the T is different. Here T is 500, here T is 5000. So you can solve it with the calculator and get the answer. So these are the problems. So you should solve all these problems yourself with your hand by understanding. So in the final exam, they will give you the problems about these slides. Okay, in all chapters. So all chapters, slides problems must solve. This is my advice, because the exam, I hope 95% will be from the slides. Okay, I think you understand, and inshallah, if you have any question, you can ask me. Okay, assalamu alaikum.